Good morning, everyone. Right, today I want to recap on interpenetration and development. This is the topic that we started during the course of the week, but because some of you might have missed that the lessons during the course of the week, so I want to go back to interpenetration and development. If possible, we are going to do 2 tasks today so that you are able to connect with what we did during the course of the week. Of course, we have moved on to transition pieces, but like I said, I want to recap on everyone so that you are able to see what exactly we did during the course of the week. Right. Like I said, it's interpenetration and development, and we are going to focus today on inline combination. All right, we did quite a number of offset combination during the course of the week, so we are going to look at inline combination. Right, the slide doesn't want to move to the next part, but basically the topic that we are looking at, we are going to look at drawing of the top view, which will be given. We are also going to look at the completion of the front view, right? We are also going to look at the left view as well, right? Which should also be completed. Right, from there, we are going to draw or construct the surface development of the branch pipe. And of course, we need to label the necessary development that we have constructed. We also need to show all the necessary constructions and hidden details if there are any. Right, so let's do this. There you go. Right, so this is what we are going to do today, right? Like I said, unfortunately, our PowerPoint could not move to the next items, but I think I read what is it that we are going to do today. So the given figure shows an incomplete front view, the top view, and the incomplete left view of a right regular square prism that has been shaped to fit around a right regular hexagonal prism. So we have got a square prism that is penetrating a hexagonal prism. The axis of both prisms lie in a common vertical plane. Right, we are also given the position of point A, which is our starting position, which is here, right? The instructions are as follows. Draw to scale 1:1 and in first angle orthographic projection the following views of the two prisms. The moment you hear first angle orthographic projection, you would know this has to do with paper 1. Right, the top view using point A as a reference point. So we have got the top view here. We are going to draw it there. The complete front view, we are going to complete this one, right? Showing the line of connection, which we refer to as the line of intersection, right? If it is curved, it is called a curve of intersection. We are also going to look at the left view. When you are looking from this side, you will be able to see this, okay? Right, but we are also going to complete that one by defining also the line of intersection. The other thing that we are going to do, like I said, to construct the surface development of the branch pipe, right? Label the surface development, show all necessary constructions, and show all hidden details, okay? Right, so we are going to start with our work now, right? We are going to look at the position of point A, right, which is here. I'm going to draw a faint line like this, right? And another one going up, like that. Okay, so just extend this like that. All right, now we are told that the side from here to there is 25. So if it is a hexagon and you are given the side like that, you measure 25. Take your compass. Right, you draw a faint circle like this, right, which is a radius equal to the side, and the side is equal to 25. Right, look at this point as well as that point, so I can stand here, right, and there. Right, I'll show you two methods. Right, describe an arc, describe an arc. You stand on the other side, you describe an arc. Like that, okay? There you go. But you can also, right, draw that hexagon, right? Once you have drawn the circumscribing circle, you can take your set square like that at 60 degrees, draw a faint line like that, and do the same like that. You would see it's one and the same points, right? So I can do that. And the other ones, they are horizontal, so we can connect like this, connect like that. There you go. I have got the framework in terms of my hexagon, okay? All right, so I can now outline this, right? Because it's not going to change, outlined from here to there. Right, so the other similar line is this, like that. There you go. Right, so I have got the framework or the hexagonal part as seen from the top. Right, the next thing that I want to do, right, I need to project this hexagonal part, right, onto the front view, which is our VP, right? Let me just create a ground line like this. Maybe that's about it. And I'll label this one X and Y, okay? I'll label that X and Y. Right, the height from here to there is 60. Right, let me measure 60. There you go. And draw a faint line. Right, I would need it on the left-hand side. We just take this one down. Right, so if we measured from here to there 60, we draw a line like that. We shall need that. Right, then I can project this. Right. There you go. Right, if you check, right, the extreme end, okay, which is this line and that line, they are not going to be affected by the penetrating square prism. So I'm going to outline this. And that one as well. Okay, right. I'm also going to outline the bottom part. Right, because it's not going to be affected. But I cannot outline the top part. As you can see, there is a small little overlap at the top. So I would wait to draw the position of the square prism, right, as well as this other side, so that we see we will be able to get those points. Now, the next thing that I want to do, right, I want to create an auxiliary view. If you check at the bottom, right, there's an auxiliary view of the square, right, which is here. But remember what we did when we are drawing an auxiliary view, create a line like that. Right, take your 45 degrees set square, like this, faintly. Right, the side of this auxiliary view from here to there, which is the side of the square, is 30. Right, so you measure half of 30. Like that. Then at 45 degrees, describe a line. There you go. Right, so that is the auxiliary view. From here to there is 30, from here to there is 30, okay? Right, I'm going to label this one point number 1, point number 2, point number 3, and point 4. All right, then project these now to meet the hexagonal prism, right, like that, faintly. Right? Right. I cannot complete this top view without the framework of the left view. Okay. So what I need to do, I need to position the left view, which is this one, right, in position. So I need to create a new ground line. Let me create a ground line. There you go. Okay. Right, I can call this ground line x1, and at the bottom y1, like that. So I've got the ground line x, y, and x1, y1. Okay. Let's lift this. All right. Now I can take a 45 degrees set square. Right, faintly. Right. So if you are looking from the left-hand side, you are going to project the left view this side. So this one, take this one up like that. Right, let me just label this point A, B, C, D, E, and F, okay? Right, such that if we project here like this, and we also project there like that, we'll also establish the framework in terms of that hexagonal prism. There you go, okay? Right, so here I've got F and E, which is also F and E. Right, I have got A and D. I've got A and D. Right, I have got B and C, B and C. When you are looking from the left-hand side, right, you would realize that when you are looking from the left-hand side, right, in terms of this point B in line with point C, A in line with point D, they don't interfere with the penetrating square prism, okay? So you can as well outline this like that. And also this one is not going to be affected like that. Right, but I'm not going to outline this one, okay? Right. What I can do, I can outline the top part and the bottom part of this one like that. Remember, always work from the known facts to the unknown. Right, so these are obvious lines. You'll get marks for drawing those obvious lines. Right, if you check on this one, there's a height which is given from here to there, which is 30. Right, so I'm going to measure 30. Right, and also there is an angle that has been defined, which is 30 degrees. Right, I'm going to draw a line like that. if you have got an auxiliary view this side, you also need an auxiliary view at the top. Okay, so I'm going to create an auxiliary view, the same square. I'm going to do this, right, at 60 degrees like that. Now, remember what I did. If you want to draw a square at an angle, right, you need to create a line which is 45 degrees through the two lines like that, right, and the square is 30 in terms of the side, so you measure 15. Maybe let me just explain. Right, I've used this set square, right, as the edge of this set square, right, in order to give me an angle of 45 degrees. So remember, this is 45, this is 45. So this one is acting as the edge, which is supporting the 45 degrees set square, not necessarily the T-square. The T-square is supporting the blue set square. So once you have done that, you can now project via that point. Make sure everything is perfectly supported, like this. Right, you slide. Right. Slide as well. Like that. If you slide from here, it should give you that. Okay. Right. So now I have got an auxiliary view with regards to the left view. Right. I'm going to use a different color. Right. So I would say this is 0.1, this is 0.2, 3, and 4, like that. Right. So that we are able to see. Right. Okay. Right. Then from there, you would need to project from this point. There you go. Like this. Okay. Right. If you check with regards to the setup, from this edge to that one is 12 millimeters. So I need to measure 12 millimeters from this point, mark like that. Then take this one up like that. So this is where the branch pipe would start. Right. So at that point, I can now draw at 60 degrees like this. Okay. Can even outline this. It's not going to change now. There you go. Okay. Right. Then I can come here and complete this. Right. Complete this. Right. Remember, it's not necessarily complete. We still have to find the extent of those lines. Okay. But we are just copying the way it is given. Right. And also, let me just redraw this so that I want to use a different color for the branch pipe, like that. Just going to make it slightly heavy, right, just to define that. Right, so I wanted this one to be in red. I hope I will be able to show that one here. Right, then the hexagonal prism, I want it to maintain the blue color. Right, so I'm going to extend this like that. Right, now if you check, right, this point is slightly overlapping, right, so I can project it like that. Right, you'd find that is slightly over the point, okay, right, which is this line, the top part. Now this point is point number 1, right, this is 2 and 4, right, when you are looking from that side, this is point number 3, okay. Right, so if we project from here to the mitre line, project from here to the mitre line, project from here to the mitre line, and combine with these projectors which are coming from this auxiliary view, you would find that we would end up being able to draw this part, which looks more like a rhombus, okay? Right, this part, which is what you are able to see when you are looking from the top. You are not going to see the true square because it is drawn at an angle, okay? So you are going to see a squashed square, okay? Right, so I'm going to project from here to the mitre line. Let me do this. Right. Now, if I take point number 1, right, which is here, that would be my point 1. Right, that would be my point 1. Right, if I take point number 2 and point number 2, that would be 2. Right, if I take point number 3, hitting the surface and dragged here, that would be point number 3. Then 4, hit the surface, then point number 4 would be here. Right, that is in combination with this one. Right, join these points. Right. Here we go, okay? Like I said, I want to define this edge of the branch pipe in red so that we see the difference in terms of the two solids that we are combining. There you go. Put it in focus. Right. Now, this can now be completed and taken to meet the hexagonal at that point. At that point, you can also do the same. Like that. Right. So now this is the branch pipe, which is exactly what we have here. The only thing that is missing when you're looking from the top, you won't be able to see this line 3, 3, okay? Right, so this is also point number 3. So I'm going to extend this by way of hidden details. There you go. Right, so this line, which is at the bottom, is now represented by the hidden detail, but because there's an outline already, that would take precedence, okay? Right, I have got my top view now complete, okay? The next thing that I want to do, right, is to define the line of connection, right, in terms of the prism, which is the square prism, and the hexagonal prism. But maybe before we do that, we can also come about or define this framework, right? I've got point 1 here, right? If you check, that's point 1. Right, so I'm going to label again. Right, that's point 1. All right, then point number 2, project from here like that. Right, I need to extend these lines up like that. Like that. Okay. Right, so there is point number 2, there is point number 4. Then I need point number 3. All right. This is 3 and that is 3. So we have got 3 here. Let me use the appropriate color. That's 2, that's 3, and that's 4. Okay. So the next thing is to connect this, right? You'd find that we have gotten that part. Remember, all these are marks that you should not throw away. Start with the obvious. There you go, okay? Right, so when you are looking from this side, which is the right, you will be able to see that. When you are looking from this side, you will be able to see this, okay? Right, so I'm going to outline this one. Remember, if you are seeing this one at an angle, it won't be a perfect square, okay? It will appear a bit squashed. All right, so now I can go back to that top part and do this. Right, outline from here to there, then hidden detail, then outline from here to there, okay? Right, because that edge is still there, so that's why we showed by way of a hidden detail. Right. The next thing that we want to do now, right, is to factor in. Look at this. When you are looking from the left, right, we have got this line, right, that is 4, this is also 2, like that. This is 1, 1, and there's a 3 there. Right. So if I were to project from here, like that, to the mitre line, I'll take this one up, like this, right? You would realize that when you are looking from the left-hand side, there's absolutely nothing that would stop you from seeing this line 4, 4. So I'm going to extend line 4 up until it meets that one and outline that. Like that. So there I've got another point number 4, like this. So I can extend this with confidence. That would not change, okay? Right, as you can see, point number 4 is in line with point number 2. So we can also label here. This is also point number 2. So we have got 2, 2, and we have got 4, 4. But what you'll be able to see when you are looking from the left is line 4, 4. Right. Then the other thing that we are going to see, right, if we project, this is the connection between the square prism for point 1, right, like that. But what is critical, right, is for us to be able to, for point 1, you'll find that it will still be there. For point 1 here, point what? Point 3 here, okay? Right, but what I want you to do, right, there are these 2 points, this one and that one. So let's call this one X and Y. The X would be at the top and the Y would be at the bottom. And this one, I'm going to call it M and N, okay? Right, this is for construction purposes, right? You can bring this line backwards, right? You can bring it backwards, like that, right? Now, this would be our X, this would be our Y. Between 1 and 4, it's X. Between 4 and 3, it's Y. 1 and 4, it's X. You can also have it here. Between 4 and 3, it's Y, okay? So let's deal with this one. You can project from this point, which is the completed top view, right? Or you can take the measurement from here to X and go between 4 and what? And 1, right? Insert X like that, right? Let me start with this one so that you will be able to see. Right? Take this one, right? Take it up. Like that. there is the point that I want, but not the completed point. So then you can now project it to the auxiliary view like this. Right, okay. Right, remember what we said, right, between 4 and x. Between 4 and 1, there's an x. So this is 4, right, which is x there. Right. If you want another one, right, for between this one, you project it down perpendicular like that, right, which is the same as this one, okay? Right, this is 4 to number 3, right, there is a 1, so you are going to have 0.1. Like that. Now, you take this one also backwards, like that. Right, as you can see, if we project this, would be the same, right? Would be the same as M, right? Which is between now 1 and 2, right? So I will not waste the time, and I'll write here M, and I'll write here N, between 3 and 2. Okay, just for you to see. Right, so M is between 1 and 2, and N is between 2 and 3, like that. Now, so if, say you are moving from point number 1, right? You're moving from point 1, which is here, right? We want to do it methodically so that you are able to see. Right, we said here it's point M. Let me just project so that we verify. Right, this one would be point N. Should see it's 1 and the same line like that. Right, if you take this one, it will be the same point. Do you see that? Okay. Right. So if we project here, let's start at point number 1, which is 1. Right. So from 1, you don't go directly to point number 2. You pass through M. So this is our point 1. I want you to pay special attention here. From 1, you go to M. From M to go to point number 2. So 1, right? Let's project M, and M, it's here. So I've got point M there. Right. Once you have gotten point M, you now go to point 2. So you need to connect. You need to connect like this, faintly. Right, then from 2 you go to N. Right, let's look at this. This is the line N. Right, where is my N? Right, you'll find that it's here. Right, so there is point N. Right, so from 2 you go to point N like that. Okay, from N you go to point number 3. Right, from N you go to point number 3, which is this one, right, which is that, okay? Right, once you have reached point number N, you now go to point Y, okay? Right, projection, we'll see there is point Y as well, okay? Right, then from there, you now go to point number 4, which is 4, in line with point number 2. From 2, you go to X, right, which is this one. So I'm going to say this is also X, like that. Then it will take you back to point number 1. So I'm going to outline this, right, from 1 to M, okay, right, and from M to 2, like that, right, and 2 to N, right, this one, from N to point number 3, like that. Then from 3 you go to Y, from Y you go to 4, from 4 you go to X, X back to point 1. So what we have done here, we have now defined the line of intersection. So this is how this surface would be connected to the surface of of the hexagonal prism, okay? The surface of the square prism will be connected to the hexagonal prism like that. I hope you are following and I'm not confusing you, right? Because I don't want you to be confused, especially when you are looking at the time you are right now in preparation of your exams. So I hope this is consolidating your understanding of interpenetration and developments. Right, okay. So looking at this, we have completed our left view, okay? We have completed our left view. Now what we want to do, right, is to project these points, right, to the front view, right? Let me start with line number 3, like that, right? So 3 is here. Take it up, and this is also point number 3, right? I'm going to use a red pen, like that, right? Then the other 3 is already there, right? I'm also going to project number 2, right? So there is my number 2, right? I'm going to connect this one. 2 is in line with point number 4. So there's 2 and 4, okay? Right, this is N, like this, right? I look for N, there is my point N, right? N is in line with Y, there is my point Y, okay? Right, then I move away from there, I go to M and X, like this, right? M, it's here, right? And X is there. Right, then from there, I move on to point number 1, right? There is my point 1, which is here. So it's 1 to 1, right? Which is 1, 1, like that. Remember, we are making an assumption that this part is open, right? It's meant to transmit something. So from this pipe to this pipe, okay? Right. Now, how would you start? Remember, I started from 1 to M, from M to 2, okay? Right, just to correct this one, our point M is there. Slightly, it's here, okay? So it's point 1, which is wrong. Right, I'm going to do this, right, faintly. Right, from M, I now go to point number 2, which is here. Right, I'm going to connect like this. Right, from 2, right, 2, I go to M, which is that one. Like that. From N, I go to A3, which is here. From 3 to 1, then Y to 4, 4 to X, like that, and X to 1, you come back like that, okay? Right, now there are certain things which are obvious. When you are looking from this side, there is an obvious line that you'll be able to see, which is line 3, 3. So I'm going to outline this like that. There you go. Okay, line 3, 3. Right. Then there's also line 2, 2. Right. You have got 2 this side. Right. 2 and 4. Okay. They are on the outside. They are on the outside. So they don't interfere with anything. So I'm going to also outline this like that, and this one like that. Right, there's a connection between 4 and 3, but via point 1. Right, so I'm going to do this. Sorry about that. Then now to point 3. There you go. Right, there's also the connection between 2 and 3. This. Then to that point. Right. Now, this line, by virtue of crossing a defined outline, automatically this is a hidden detail, okay? Right, so I'm going to define this one as a hidden detail. The same applies with this. Okay, if you check, but you also don't see this H11, but so from the top there, right, you would show this one by way of a hidden detail and connect this one as well because the H is on the outside. Right. So you now have got the line of connection, right, where this square prism is meeting with the hexagonal prism, right? Now we can go back in terms of our hexagonal prism, right? We know that this point F, right, it goes down, but it is meeting the square prism here and also meeting it there, right? But the rest from here to there, it's visible when we are looking from this side. So I'm going to outline this from here to there, right? And also show now, because it's covered inside, then outline from here to there, okay? Right, so from here to there, from here to there, that is the extent of this line FF. We have got the same scenario for E, right? We come here, outline from here to there, and show hidden detail here, then proceed with an outline like that. Okay. All right. Now, but if you check closely, you would find that in line of point C, or in line with points F, as well as point E, there is point B and C respectively. These points, right, which are the lines from the top to the bottom, they have not been disturbed at all. So what it means is that that H is still there. So it has to be represented by a hidden detail. The same applies with C, a hidden detail, like that. Right, so we have got this from here to there, but we only see the hidden detail because in front there is point E, which is stopped here and which is stopped here to there, okay? Right. If you do this, right, in terms of the answer that is required, right, we have now completed the front view, right, as required in the question. So we can even go back to the question and check what is it that we were asked to do. Right, to do the top view, we did that. Completed the front view, we did that. And we also completed the left view. Right, do this to check whether you have answered all the aspects of the question. The next thing that you're required to do now is to construct the surface development of the branch pipe. Right, remember the upright one is the main pipe, this one is our branch pipe. All right, okay. Now, we do have a lot of space this side, so we can make use of this space by extending the baseline and stepping 4 times in terms of this. Right, so I'm going to do this. Extend this like that. Right, find a starting point like that. Right, let me just check if we're given the seam. Right, the seam is not specified. Right, so I'm going to take this 1, 1 as our seam. Okay, right, so we are going to open through point 1, right? Then we unroll our shape. Right, so here is our point 1. Let me now use a green color. Let's hope it's visible, not so visible. Right, let me try black like that, okay? Right, so that is our point 1, right, here. Right, so you go back to the auxiliary view because the auxiliary view defines the true size of the geometric shape, right? When you are looking from a specific site, right, you can take from here, this is point 1 to 2. which again, right, you can measure 30, 30, 30, but we don't want to continuously measure, right? So I'm going to stand there, describe an arc like that. I establish point number 2, right? Stand there. Point number 3 and point 4, right? If I start at point 1, I should end at point 1. So I've got point 2, point 3, point 4, back to point 1, like that. You take your set square, like this. There you go. Like that. Right, so from here to there, that will be the extent of our development. Right, that will be the extent of our development. Right, now you need to project from here all the points. Right, this is for 1 and 1. So I'm going to project like that. Right, this is for M and X, like that. Right, this is for N and Y and 3. Right, 2 and 4, like this. Right, so all the points which are on the line of development or line of intersection, they should now be projected so that we can define the development. All right, so here, from here to there, and from here to there, that would not change. So I can even outline from here, right, like that. There you go. Right, and also define the base by outlining it fully like that. Right, so from point number 1 to point number 1. The next thing that you want to consider, you now take the measurements, right, from point 1 to point M. Right, point 1 to point M towards point 2. So we are going to mark. There is your point M. Right, so I'm going to write here, that's my M, right? Let me see. Yeah, so it's from 3 to N, okay? Right, towards point 2, that's my N, right? I'm going to write N like that. Right, then other one is 3 to 4, right? I'm going to have this one is this one, right? Then from it should be from 1 to 4, correct? 1 to 4, right, which is this one. This 1 to 4. Don't mix 1 to 4 and 3 and 4 to 1, otherwise you'll make a mistake. Check the distance from here to there, right? It's 1 to X towards point number 4, right? Which is not the same as the same distance from 4 to X when you are standing at 4, okay? Right, so you have got point X like that. Right, then you project these faintly, project them up like that. This is N like that, like that, okay? Right, so we can start by looking at this. This is 1 to M, which is 1 to M, right? Let me just bring this one down. 1 to M, which is 1 to M. So from here, right, to M, which is this point, right? So I can say this is M, right? Then from M, I go to point number 2. Right? Point number 2 is here, right, which is there. Then from there, I go to point N, Okay, right, where is N? Right, N is here. Right, that's my point N. Right, from N, where do I go? I go to point number 3. Right, where is my point number 3? It's here, so I will label this one 3. Right, 3 to Y. Right, this is Y. Right, 3 to Y. Where is my Y? It's here. Right, in line with N. Right, from Y I go to 4. Right, 4 is here with 2. Right, from 4 I go to X. Right, X in line with M. That's X. Then from X I now go back to point number 1, which is this one, which is this one. Right, remember I'm simply labeling this so that you will be able to appreciate and understand where we are taking these points from. Okay, but otherwise you may not necessarily label like this. Connect these points from 1 to M like that, and then from 2 to N to point number 3. Right, number 3 to Y. Then 1 to 4. Then 4 to X. And X back to 1. There you go. Right, so we have got the framework in terms of our development. I'm going to outline these cut lines. Right, so from here to there. Then there you go. Right, the next thing that I want to define, what about that? Right, is the issue of the fault lines, right? This is the cut line, right? Then I have got here 2 to 2. I'm going to use a red color so that we are able to see, right? 2 to 2 and 3, 3. That's also a fault line, right? Then you have got 4, 4. That's also a fault line, right? Then this other one, right, which is the line that you created. I'm going to use green, right, like that. That's for 1. There you go. All right. So this is now the development of the transit of the branch pipe. Okay. Right. So that's the development of the branch pipe. Then you can label, right? Either here you label, right? Development branch pipe. That's the development of the branch pipe. Right. So now we are done with this question. Let me just check. Right. We did develop that. Label the surface development. We've shown all the construction and all the hidden details that are required. Please just make sure that every time you are drawing, you should be able to link with the question and find out if you have answered all the aspects of the question, okay? But you don't want to leave certain parts of the question which you know, but simply because you didn't check. So I want you to make sure that you connect with the question, right? Check whether what we have done is what the question was demanding from you. Right, so boys and girls, right, this is it. This is the development with regards to the two prisms that are meeting, right? They are meeting at an angle. They are in line simply because whatever detail that we are able to see when you are looking from this side is also covering the other detail which is at the back. So I hope you understood this one and it has been helpful to you. I'm going to look at another question, okay? But now this one would include a bit of circles so that we touch everything with regards to interpenetrations and development. Right, so I now have brought a new exercise, right? It's a new task, right? Which is basically to do with interpenetration and developments, right? But as you can see, let me just read the question so that you understand what we are supposed to be doing here. Right, the given figure shows the incomplete front view and top view of a cylinder that has been shaped to fit around a right regular hexagonal prism. The prism is coming back again. The axes of both solids lie in a common vertical plane. The position of point A, point B, and point C in terms of the starting positions, we are given those. So we've got A, B, and C. Right, instructions: draw to scale 1:1 and in first angle orthographic projection the following views of the two solids. The top view using point A as a reference point. Right, so we have got the top view, right? We are simply going to copy this one, but as you can see, right, it's not complete, so we might need to complete that. The complete front view, the right view, what you are seeing when you are looking from the right-hand side. Then construct the surface development of the branch pipe, start at point B, right? Construct the surface development of the main pipe, start at point C. We are going to do that. Right, construct label both the surface developments, show all necessary calculations and constructions, show all hidden detail, okay? Right, let's start with this one. Right, we are supposed to draw this hexagonal part here, right? And just to check if my paper is well set, that's fine. Right, let me draw a faint line like this, right? And another faint line going up like that, right? We are not given the side, we are given what we refer to as the distance across flats, which is a diameter, okay? Right, so I'm going to draw a circle with radius 20, which means the diameter 40. So measure 20 here, like that. Right, take your compass. Right, you draw a faint circle like this. All right, if it is across flats, right, I'm going to draw the flat this side and another one here, like that. Then I can take my 60-degree set square, right, drawing a line which is tangential to, like that, touching the circle but not getting into the circle, like this. Again, here, at 60 degrees, at 60 degrees. Right, if you are satisfied, you can outline this now, like that. Right, I can also outline here. There you go. Right, then complete the top part like this and like that. Right, now I have got my top view as given, which is the top view, right? The next thing that I want is to project this top view so that we can be able to generate the front view. But let me just leave some space here, create a ground line like this. Right. Ground line. Right, and I would label this on X and Y, okay? Right, what is the height? The height from here to there, it's 70. So I would measure 70. It's not visible from that end. Let me take this one down. So from here to there, that's 70. Right, then draw a faint horizontal line like that. Now, I can take this one up. Like this one. There you go, okay? Right, I can say this point, that's my point. Let me say this is point A. Let me go anti-clockwise. A clockwise rather, C, D, E, and F, okay? Right, now, this side with regards to the front view is not going to be disturbed at all, right? Right, as you can see, there's a line, but let me wait for now. Right, let me define the extent in terms of the branch pan, right? I've got this point, okay, which is basically that point drawing at 45 degrees. So from here, at 45 degrees, faintly face. We'll define those lines later. Then can create a line like that. Right, so as to be able to draw an auxiliary view. Right, the side of the cylinder is diameter 36, right? Diameter 36, which is radius 18. Right, so I'll take this one, radius 18. Right, stand there at the center, like that, and describe, oh, sorry. Describe an arc like this, which is a semicircle. Right. Remember, it's at 45 degrees. Right, so use a 45 degrees section. Then you take this one back, like that. Now, where these projectors meet this line, if you check the setup, you find that this point and that point, they are in line, okay? Right, so I can even now outline this, like that. Then also outline this, and outline that. Keep making same mistake. Right, okay. I needed to make sure that I differentiate here. I'm going to just type in this with the red one. There you go. Okay. Right, so this one, the branch pipe, I want it to be in red, and the main pipe, I want it to be in blue. Right, okay. The next thing that you want to do, right, since this is drawn at 45 degrees, I'm going to divide the semicircle into 6 equal parts using a canvas. Right, I'm going to do this. Stand there, cut there, and also cut there. Okay. Right. So the issue is you stand there to describe an arc to cut the circle. Right. I'm going to say this is point 0, 1, 2, 3, 2, 1, and 0 like that. These lines cannot be projected. Remember, it's at 45 degrees. They cannot be projected from here. Like that. That's for 1. Right, okay. Now, if I have created an auxiliary view here, right, I would also require an auxiliary view this side so that I can coordinate, right, as they hit the surface, and these ones which are coming from here, right, let me just drop this one, like that. Then mark a point and draw a line like this. I would also draw the semicircle. If it is horizontal like this, there's no need for you to use a canvas, because you can make use of a 60-30 degree set screen like that. There you go. Okay. Right. So there will be projections from here. Right. Now, in terms of labeling, I've got 0 and 0 on the outside. If it comes here now, this is 3, 2, 1, 0, which is now in the inside, 1, 2, and 3. Right, you find that if you were to draw it first in terms of the right view, because we are going to have a right view here, right, you would have the same arrangement in terms of numbering. Right, I'm going to do this. We create a ground line like that. Okay. All right. Label this ground line x1 and y1. Create a meter line like this. Let's hope it's going to fit. Yes, it is. Like that. And take this one up. That's just to make sure that you have got sufficient space in terms of your drawing. But I take this one like that. Okay. I'm going to project here all the way to the meter line. There you go. Okay. Right. Now I want to complete the top view. Right, the top view is completed by dropping from here, from the projectors from the auxiliary view, meeting the projectors from this auxiliary view. You'll find that we are going to create an elliptical shape. So this is point 0, like that. The other point 0 is already there. Then from there, I go to point 1. Right, point 2. Let's check something. Okay. Right, it was off slightly. Right, now there is 0.0 here, there is another 0.0 there, okay? Right, so if you know that you did your constructions properly, you find that this will be a 0.3, then 2, 1, 0, 1, 2, 3, 2, 1, 0, 1, 2, back to number 3. Right, then you connect these points currently like this. There you go. Okay. Let's out a little bit, which is this point. There you go. Okay. Right. Then I would take my red pen. Right. So now this is the surface that you are able to see when you are looking from the top. Once you've done that, you can now connect with the hexagon or the hexagonal prism. Okay. Right. The next thing that you want to have, right, is the issue of the center lines. So I'm going to show. Also here, to show like that. So you now have got, you have completed the top view, right? You've completed the top view. The next thing that you would require now, right? Remember there are projections which are coming from here, right? These projections can now be taken up, right? And be coordinated with these ones. There's nothing that would stop us from outlining from here to there. Right. As you can see, right, this branch pipe which is coming from the right hand side, it's not interfering with this point F and point B, okay? Right, it's not interfering with this C and E as well as D, so we can even outline this. There's nothing that would stop us, right, like that. Then I can come here and also outline from here to there, right? I can outline just from here to there and from here to there, like this. Right. Also the bottom part. There you go. Okay. Right. Now I need to project from here. Right. This is for point number 3. So like that. Right. This is for point number 2. Like that. Then number 1. Right. Then 0. Right. 0, which is meeting there, right, which is already there. Right. So I've got point 0, then 1, 2, 3. Right, let me extend this one. Okay. Right. So it's 3, then 2, 1, then 0. Okay. Right. Then I will create this. and turn this one like that. Right. So that is the curve of interpenetration. But let me define it so that we are all able to see. So I'm going to do this. Nicely. Then it turns back to 0.0 like that. Right. So that is the curve of interpenetration. But remember, we're talking about the line of intersection. If it is a straight line, like that is the center line. Right, remember all the details which are there, they have to be represented in order for you to get all the marks. So we now have got this line, which is the given center line. It's part of the information which is given, which is this center line. So that has to be defined as well. Now that we have got this curve of intersection, right, we can now project, take these lines up. I'm going to take these ones. Like that. Okay. So if you check, well, this is our point 0, right? So I'm going to project here. But let me start with the ones which are on the surface. So we have got point 0, which is in line with this. So 0 and 0, you would find, you'll get your point 0 there. But I'm going to go to point number 1, 2, 3, 2, 1, and 0. Okay. Right. So do I have point 3? No. I need this and this one as well. Okay. Right, okay, so I have got that. So it's point 0, 1, 2, 3, 2, 1, and 0, 1, 2, 3, 2, 1. Okay, and I can connect this. Like that. Right, okay. Then I can outline this. There you go. Okay, right. So this is the surface that you'll be able to see when you are looking from the right-hand side. Okay, right. Now you would also be able to see, right, these points, these points, these points. Some would not be as seen as defined like that, but let's project them. Right, we have got here, that's point 0, right, which would be this point. Right, then you have got point 1. You've got point 2, point 3, 2 again, then 1, then 0. Okay, right. So you have what this is 0, 1, 2. It's 2 is here, then 3, then 2 again. Then 1, then 0, 1, 2, then 3, 2 again, then 1, then 0. Okay, right. So I'm going to connect this faintly. Right, do the same this side. There you go. Okay. Right. Now, when you are looking from this side, right, remember this is our point 3. Right. So we have got the extreme one, which is point number 3, which is also point number 3. This is 0, which is 0. Okay. So I'm going to extend this one to there and extend this one to there and outline the rest. Okay. I'm going to outline from here to there, that's 3, and also this one, that's 3, right? Then this one is joined by way of freehand. Like that. Right, there is crossing of a defined outline, so this has to be shown by way of a hidden detail. Remember, this I'm showing as a hidden detail simply because the other side, the edge is on the outside. So we also have got the edge from here to there, which can also be represented by a hidden detail like that. Right. Then, if you are looking from the right, you'll be able to see A, but this A on the other side, you won't be able to see. So I'm going to outline this like that. All right. Then we are also going to see B and C, right, which is from here all the way. There you go. You are also going to see F and E, which is from here to there all the way. This is in line at the top, so we are going to close like that. Right at the bottom, we are also going to close like this. Right, but as much as you are able to see A, right, which is just here, but the other A from here to there, you won't be able to see that. You would need to represent this one, which is point D, as a hidden detail. So I'm going to show this one as a hidden detail. It's representing point D, which is on the other side, right? I need to define the center line. The center line is through that point, so I'm going to show that's the center line. Right, so now what I have done, right, if we are checking with regards to our question, the top view, which is now the completed top view with point A as a reference point, we did that. We completed the front view by defining the line or the curve of intersection. We looked at that. But looking from the right-hand side, we were also able to draw the complete right view. We did that. Like I said, it is very important for you to check your progress, right? So that you are able to see whether you have answered all the questions that are required, okay? Now, the next thing that we want to look at right now is to construct the surface development of branch pipe. The branch pipe is this one. Now, because we are given a specific starting position, right, what we are going to do, we are going to start at this very point, which is this one. So from here, right, I'm going to project a line like this, like that, and a vertical line. Like that. Right. So from here to there, we need to unroll this part, which is the development from here, right, of the cylinder. So first of all, let's calculate, right, the circumference. Circumference is pi times diameter. Right, circumference is equals to pi times diameter. Right, what is the diameter? Diameter is 36. So we are going to say 36 multiplied by pi. Right, which will give you this, which is 113. So pi multiplied by 36, which is 113. Right, so we need to measure from here to there. That's 113 and divide it. Right, so you draw a line from here to there, right, and another one going up. Then from there, like I said, you have calculated the circumference, which is given by pi times diameter, right? Pi times 36, which is equals to 113, like that. So I'm going to measure from here to there, 113, 113. This is 100, this is 110, that's 118, like this, right? Then draw a faint vertical line. A faint vertical line like that. I want now to divide this one into 12 equal parts, the same divisions that we have there. But let me take this one up. It's 12 equal parts. That's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Like that, okay? Right, if you can use an adjustable set screen, it will be faster. So I'm going to do this. But align this one to there. There you go, okay? Right, so I'm going to open through point 0 this side. So this point B is actually my point 0, which means I'm also going to close at point 0 like that. All right, so if you have got a scenario like this is what you can do now. just adjust so that you are able to see. Okay, right. So the distance from here to there, you can take and mark it off. This is for 0 and 0 this other side. Right, I'm going to do that. Take this distance, right, which is this distance, mark this side, right, that's 0.0, right, and I would just label slightly like that, draw all the way, right, because if you are starting at 0.0, you should also end at the same height. Then you take the distance from here to point number 1, right? Right, so from the base to the end of point 1, which is this one, right, your mark, like that. So this distance, you bring it from here, right, you take, like that. You can label, it's fine. You say this is point 1, like that, okay. Then the next one that you require is number 2, from here to there. Again, you take from the base, take from the base, right, you bring it here, then you mark. Right, you project a line. So we are going to say 0, 0, 1 and 1, 2 and 2. But so we have got point number 2, right? We are still going up. We are going to take 3, right, and mark this side and say you have got point number 3. Right. Now let me project these lines up. Okay, project these ones faintly like this. But remember, these are the projections from the divided circumference. Sorry about the noise in the background. There you go. Okay. Right. So this is 0, 1, 2, 3, 2, 1, 0, 1, 2, 3, 2, 1, and 0, like that. Right. So when we say it's 1, 0, and 0, that's this point. There's point number 1, and there's point number 1. There's point number 2 here. Then there should also be point number 2 there. Okay. Right. If I project this one, right, there's 0.3, there should also be 0.3 there. So we are now left with the middle ones, right? I need this is the second number 2. So I take this one from this point to point number 2, like that. Come here, you define that one. That is the other side now, right, which is point number 2. You draw a line, so you've got 0.2, and you have got 0.2, right? I now take this one, it's for 0.1. Okay, I extend here, mark this, very close to point number 2. Draw this, that's 0.1, right? So I put 0.1 and 0.1, okay? Right. Last but not least is this one, which is 0.0. We are going to dip a little bit. That's like that. Take that. That's another 0.0. Like that. So there is my 0.0. Okay. Right. Then you connect these points. And we do this. There you go. Okay. Right, if you are satisfied that you did the right thing, right, then you can outline this. Now correcting even the small errors that you might have made. Then you can close this part. Right. So this is the development of the branch pipe. Then you can label, let me just label it at the top. Development branch pipe. That's the development of the branch pipe. Now, the next thing that we want to look at, let's just check, right, the branch pipe. So we can tick that part we have done, right, with regards to the development of the branch pipe. We can say that part we are done, okay? Right, the next thing that we want to look at, construct the surface development of the main pipe. Right, this is the main pipe, which is going to be affected by, right, remember, it's going to be affected by the intersecting cylinder, okay? So we need to take into consideration all that detail, right? Now, what we need to look at is, right, let's open through point A, right, which is this point A. Right. So we are going to have this and we are going to have that remaining, but the rest of the part will be removed. Right. So I'm going to draw a faint horizontal line like this. Take this one up. Right. You also take now the height of the cylinder, which we know is 70. Right. So I'm going to measure 70 from here to there. Right. Then bring this one and do this, okay? Right, you take the sides, it's A, B, C, D, E, and F. Right, this would act as our auxiliary view. So I'm going to take this one. Like that. There you go. Right, then step. Right, if we are going to say this is point A, right, which is where we are opening through, right, so we are opening through point A, right, but if we go anti-clockwise, that will be point, right, we open through point A, which is our point A here, right, if we go anti-clockwise, that will be point B, point C, D, E, F, and back to point A. Right, so we are going to say this is our point B, C, D, E, F, and back to point A, okay? Then we project these lines going up as well. Right. Take these lines up. Right, so from A to A, let me also write this one as a small letter A so that we are representing one and the same thing. Right, so from A to A, okay? Now, once you have done that, right, you now take the distance from here, from A to this point, you can do that with your canvas standing here. You take the distance. Let me use this one. Right. The distance from here to there. This will take me to point 1. Okay. Right. Okay. So from A towards point F, from A towards point F, right, I mark like this. That's my point 1. From A towards point B, right, I also mark like this. That is my point 1 and also point 1. Right. Then you take the distance from here, right, like that. That's point 2. There you go. Right, that's point 2 from A towards point F. Right, you mark like this, right, like that. Then from A towards point B, you also mark like that. So that is point 2, that is point 2. Right, last but not least, you take this distance, which is A towards point F to get number 3, but you also come here and mark. So that's your number 3. Right, you do the same this side, you mark like that, that is also number 3. Right, you take these and project them upwards like that, like that. There you go. There you go. Okay. Right. So once you have done that, you now take these measurements from the base, which is the XY line, from here to there, that's 4.0, right? And from here to there, that's another 0.0. Okay. Right. So I will start with this one, our 0.0. Take this measurement, you bring it here, and you mark. Right, you can label as well, that's your 0.0, right? Then you project. Remember, where there's A, there's 0.0, right? Then the other 0.0 is up there, right here, right? Standing at point A, you mark. That's another 0.0, right? The next one that we require is 0.1, but the lower 0.1 would be here. It's slightly below 0.0, so you would come and mark. Okay. This is our 0.1. Right, the other 0.1 is at the top, so you take this measurement to there. Right. This is another 0.1, so there is another 0.1 as well. From there, we go to 0.2, which is the lower one, which is this one. Okay. Right, okay. Sorry, my apology for not checking the focus. Right, let me just go back to 0.1. Right, we took this distance from the base to that point, right? And we stood here and we marked that. Right, so we are going to project this friendly, right? So there's 1 at the bottom. There's also 0.0 here. There is also 0.0 at the bottom. Now I'm moving on to point number 2, which is at the bottom, which is this one. Right, take this distance, right, mark this side, That's 2. Right, you can indicate. Then you draw a faint line like that. Right, but you also need another point 2 at the top, which is this distance from the base. Right, you go to point A, you mark. That's point 2 as well. Right, you draw a faint horizontal line. Last but not least, you need point number 3, which is this one. Again, you go to point A, mark. Right, and you draw this. Right, okay. Remember, it's point 0, point 1, which is this one, and point 2, and point 3, right? Point 2, point 1, and point 0. Right, you connect. You connect this like that. But you do the same this side. That's 0, that's 1, this one, and that one. Then that's 2, 3. Right, so it's 0, 1, 2, 3, then 2, 1, and 0. Okay. You also define this one nicely, faintly. There you go. Right. If you are satisfied, you can outline this now. There you go. Okay. Right. So this is the part which would be opened out in order to accommodate the branch pipe, which is the cylinder. Once we have done that, you can now complete the rest of the part which is not disturbed. So from here to there, right, this part is not disturbed. Let me take this one up. From here to there also, this part is not disturbed. Right, then this one, you complete that, you complete that. That is the bottom part, which is this one, and the upper part, which is at the top from here to there. Right, you do the same this side. Right. Right. The next thing that I want to do, I want to define the fault lines. Remember, we've got A, B, C, D, E, F, back to point A. Let me show by using a different color. This is the fault lines. There you go. Okay. Right. Then the remainder, right, you can just make them slightly darker than a construction line, but not as dark as a proper outline. Okay, like this. But so that we are able to tell there are certain lines that you had to define in order to come up with a development. Right. Then you also do the same this side, slightly darker than a construction line, but not as dark as an outline. Right. So this is our development now of the main pipe. So you can write, let me try to squeeze it here at the bottom, like this. But I'm going to write development main pipe. like that. So in terms of our questions, right, we have constructed the surface development of the main pipe, we did that. Label both surface development, we did that. Show all necessary calculations, we calculated when we wanted to find the circumference so that we will be able to divide the circumference into 12 equal parts. Show all hidden details. Where they were need for hidden details, we were also able to show those hidden details. So, boys and girls, right, this is what I would expect you to do with regards to your interpenetration and developments. If you are given a task like this, right, the approach, how you go about it. Remember, we started by looking at the square prism intersecting a hexagonal prism. Now we also looked at a situation whereby we have got a circular geometric solid meeting, right, a prism, okay? And the type of line that we produce, like I said, it is referred to as the curve of intersection, okay? Right, I hope this has been fruitful to you and you have enjoyed this lesson. And I hope to see you again when we meet in the next session. Right, I see there are no questions in my chat box, so I'm going to end this lesson now here. Good day.